Hello and welcome to Nikolai's genetics lessons, and today's problem is: assume that an affected sister of an albino asks you how likely is it that her child with a healthy unrelated man will be an albino. Her parents are both unaffected. Assume again a carrier frequency of 2% in the general population. And here's the 5 answers to choose from. As usual, I recommend you to pause video here, try to solve this problem on your oven first, and when you would be ready you can run video again and you can compare your answer with my answer and explanation. In order to solve this problem, first of all we have to build a pedigree of this family. We are told that we have two siblings, one of them female, and she is not affected, but she has another sibling that is affected. So for example, it can be a male or female. It is not specified in our problem. Let's say he is a male and he is affected, and we also know that this brother and sister has parents who is not affected. So far we can say that because this is autosomal recessive genetic disorder, phenotype of this affected male would be small a allele, and genotypes of the parents who are unaffected would be capital A and small a. And as for this female, we also know that she marries unrelated male, and now we have to find probability for the progeny to be affected. So this is not sex linked genetic disorder, so sex of the progeny is not important. So what is the probability for this female to be also a carrier? And probability would be, because we know genotypes of the parents, so her probability would be, so parent 1 on top, parent 2 genotype here on the side, and now we can tell the probability for this female. So this is going to be our proband, and capital A here, capital A small a here, capital A small a here, and small a here. So as you see, we know for sure that she doesn't belong to this genotype, otherwise she would be affected. So she have to belong to this phenotype and this genotypes. So her probability of being a carrier would be 2 out of 3. So we know that she belongs to this phenotype, and her probability to be heterozygous or carrier would be 2 out of 3, not 2 out of 4, but 2 out of 3, because we know that she belongs to this phenotype. So 2/3 is her probability of being a carrier, so to be capital A and small a. And probability for her husband to be a carrier or to have genotype that is capital A small a would be 1 out of 50, or 2%. We can also say 2 over 100 or 1 over 50, which is going to be the same 2%. So now we are ready to do our final calculations. So probability for this female to be heterozygous would be 2/3. So 2/3 probability for female to be heterozygous. We have to multiply by probability of her husband to be heterozygous, which is 2%, or 1 over 50. 1 over 50 probability of being heterozygous for her husband, and if these two people are heterozygous, it doesn't mean that 100% of their progeny would be affected. As you see, only quarter of the progeny, regardless of the sex, because this is not sex-linked genetic disorder, would be affected. So we have to multiply by 1/4. 1/4. And the answer would be 2 multiplied by 1, and by 1 is going to be 2. And 3 multiplied by 50 would be 150, multiplied by 4 would be 600, and we can reduce by 2, so we are going to get 1/300. So this is going to be probability for this couple to have affected child, and as you see, this is answer C. And this is all for today. Thank you for your attention. Please subscribe for my new videos that I post almost every day. Thumbs up if you like this video. Write your comments, questions if you have any. Share this video with your classmates. And see you in the next video. Goodbye.